All right, if we have a vector u, it can be any length, but a lot of times what we want to do is if we have a vector, we might want to scale it down so that it's a unit vector, but in the same direction. Let me show you what I mean about that. So let's say this green thing is our vector v, and we might want to scale it down to have a vector that's going in the same direction, but that only has a magnitude of 1. The way we do that is we take our vector v and we divide by the magnitude, and that's going to scale that vector down to this little pink one here. Okay, so a vector going in the same direction, but with only a magnitude of 1. So if we want to find a vector, a unit vector that goes in the same direction as 6, -1, but we only want it to have a magnitude of 1. So let me draw that very poorly. Okay, so right now we have this vector v, 1, 2, 3, 4, 5, 6, and down 1. Okay, so it looks like this. Now, I want a unit vector that goes in the same direction, but that's only 1 long. So I want to find this little guy there. Okay, so the way we're going to do that is to find our unit vector. We are going to take our vector v and divide by the magnitude of v. Okay, so our vector v is 6, -1. And we're going to divide that by the magnitude of v. Remember, magnitude is just the distance formula, and we can use the shortcut distance formula. So we're going to do 6 squared plus -1 squared. So we have our vector v divided by the square root of 37. And then we're going to just divide both of those components by square root of 37. Don't worry about rationalizing this. So we have 6 over root 37. I don't know. Let me try that again. That was really very poor handwriting. So 6 over root 37. And then our y component is -1 over the square root of 37. Okay, so that's our unit vector in the same direction. Now, this is on your homework. You have to verify that this actually has a magnitude of 1. So we want to find the magnitude of our new unit vector of u. So remember, that's just the distance formula. We're going to use the modified distance formula. So we're going to take the square root of our x component, 6 over root 37 squared, and our y component, -1 over root 37 squared. All right, so that's going to give us 6 squared is 36. The square root of 37 squared is 37. -1 squared is 1. The square root of 37 squared is 37. And that gives us the square root of 37 over 37, which is the square root of 1, which is 1. So we have just verified that we have a magnitude of 1. All right, let me show you one more of these before we move on. So we want to find a unit vector in the direction of -2, 5. So again, to find a unit vector, we take our vector v, -2, 5, and we divide by the magnitude of v. Okay, so we're going to take this -2, 5. We're going to divide it by the magnitude. Remember, magnitude is just modified distance formula. So -2 squared plus 5 squared. So that's going to give us 4 plus 25. So we get -2, 5 over the square root of 29. So we have -2 over root 29 and 5 over root 29. And again, to verify it, you're going to have some of these on your homework. You would need to find the magnitude of u. Just show that that is, in fact, 1. And that's, again, the modified distance formula. Okay, I'm not going to walk all the way through that one. Very similar to the last problem we did. All right, so if we have a unit vector, let's say we have this unit vector u, and it has components x and y. So it ends at this coordinate xy, which means it's x this direction, y this direction. It is pretty easy to see that cosine, remember cosine is adjacent over hypotenuse, so the cosine of theta is x, and the sine of theta is y. So we can rewrite our vector xy as cosine theta, sine theta, and we can write that either in component form or linear combination. We call theta the directional angle of u. Okay, so it's just the angle that we're at. Now, it's really easy to see that if you want to take the tangent of theta, it is just opposite over adjacent, which is y over x, or if you're written this way, it is b over a. Okay? That is key. You need to know that. We're going to use that a ton. So the directional angle can be found by taking your y component. Tangent of theta is your y component over the x component. And we'll see this when we draw these as well. All right, so let's find some directional angles of these vectors. So the first one we have is negative 6i plus 6j. Let me draw that. Draw coordinate plane. So we're going left 6 and up 6, looks like that. What we are trying to find is this directional angle, theta. Now, some of you may already know it, but let me show you exactly how we get it. So what we just learned from up here is that the tangent of theta is b over a. And tangent of theta, so our b is 6 and a is negative 6. So we have tangent theta is negative 1. Now, you can go ahead and do this in your calculator. We're going to be in degree mode for now. If you do this in your calculator, you're going to do inverse tangent of negative 1, and your calculator is going to tell you negative 45 degrees. Okay, make sure you're in degree mode. Now, negative 45 degrees, that's down here. That's in the wrong quadrant. So we need to adjust. We need to be able to say like, oh no, it's in the other quadrant. We need to add 180 to that to get it in the second quadrant, because clearly the vector I drew was in the second quadrant. So theta is actually 135 degrees. So you can use your calculator to find these. You just might have to adjust to be in the correct quadrant. Let's take another look at this. This one, we have a vector negative 7i minus 4j. So this vector is going to be 7 to the left and 4 down, something like that, okay? We are trying to find this angle, theta. So we know that the tangent of theta is b over a. And in this case, b is negative 4 and a is negative 7. Of course, the negatives are going to cancel out. Now, this is not one, like the last one was a special right triangle. We kind of knew that that was going to involve a 45-degree angle. This one's not, so you just have to go to your calculator. You're going to do inverse tangent of 4/7, and your calculator is going to tell you 29.7 degrees. Now, clearly 29.7 degrees is over in this quadrant, okay? We can see that we need to be in the third quadrant, so we are going to have to add 180 to this. So we have to adjust it, so we're in the correct quadrant. Our answer is going to be 209.7 degrees. In the next video, we're going to look at a ton of applications for how we deal with these directional angles.